It's a very small circuit. It's gonna be a battery charger. So it's gonna have power supply go into a transistor with a specific voltage, transistor into resistor to limit current. That is gonna feed directly into the battery at the transistor voltage, and then it's gonna be grounded on the other side. And on that line, there's gonna be a diode that when a certain voltage passes from the battery, it's gonna feed into a resistor and into a LED light and then ground it up so that I can know when a certain voltage on the battery has been passed. Now that I think about it, I can see maybe a couple of things going wrong. For instance, I think battery chargers do have measurement for current, because I don't think you can measure the voltage directly without touching the battery, which complicates things a little bit, I'm not gonna deny. But let's see, I already drawn it and it's pretty simple, so I kind of want to build it. Now, why this is gonna take so long is because of this. I'm actually gonna try to record everything I do, because, you know, building stuff actually requires building stuff. Things don't just get built. And I have never done this before, so it is a learning process. Starting with this, I have many batteries here. This is a battery pack that I taped into a speed controller for an electric bicycle that I had. And we're gonna open this up and use the batteries from here, because, you know, this is not gonna be the first battery that I'm gonna use. I'm not gonna buy a single-use battery for this specific circuit. Also, I am confident enough that I'm not gonna fuck this up, because at this point I have burned one battery. I burned the battery from my old phone. It went into flames and it killed my phone, and that sucked. But at least now I know, you know, it's just a good learning experience, I guess. Battery fires, you have to be careful, especially for packages where there's many batteries involved, but they're not the end of the world. You know, if one catches fire, it's completely fine. And I am gonna open this up and use one battery, so it shouldn't be a problem. So let's proceed. Everything's rusted and dirty. You know what? Oh, you know what? I kind of wanted to talk about. There was one thing I wanted to talk about. That thing was, you know, me fixing my phone. With the thing of electric vehicles coming into the market and stuff, everyone kind of wants to talk about. There's a movement right now for right to repair. Everyone is going crazy about, oh, this should be serviceable, there has to be right to repair, software locking is bad. these big companies making it impossible to like use the stuff once and again. And I'm completely into it. I'm not gonna deny to you. I like the idea of right to repair, and I think it's a good thing in the world. But it has a major drawback, and I didn't think this one until like quite a bit after. But here's a major drawback, and I figured this drawback because I saw a video of a guy called Monroe Live, when they were kind of tearing apart the batteries from an F-150 Lightning. And I have to say that their approach to manufacturing the battery, you can clearly tell that they wanted the battery to be able to be opened. They clearly wanted to make it possible for a cell to be replaced or a module to be replaced easily without affecting the rest of the battery. Which you could say it's good. But when I got to see on like the size of a car battery, you can clearly tell the compromises that they had to take. Like, the design sucks. It's complete garbage. And that is one of the side effects of having, serviceability into a product like so much. Like, when you only think about tearing apart a product when designing it, the thing is going to be easily broken and taken apart. That's just how the thing is going to work. And that makes it not as reliable as you could think, which is not good on like when products are designed to be taken apart. The thing that made me realize this the most is this. As I said, give me 1 second. Let me open this up so that we can take out one battery, and then I'm gonna keep talking about my story. It's right here, right? I remember now. I already did this with another package, so I kind of do know more or less what I'm getting into. But I do need to be a little bit careful. I don't want to damage anything inside. Me slow. Your love is all I got. As you holding mine, baby. Okay, so back to the story. I had a Samsung Galaxy Note 20, and I bought it probably like 2 years ago. By the way, if you're gonna do this, wear gloves. This was incredibly stupid by me because I'm not wearing shoes and I'm touching the floor. So you can get electrocuted if you're not wearing gloves and no shoes. This battery is uncharged, so I know it's kind of safe, but don't be stupid and wear gloves if you're ever turning down a battery. In fact, I am probably gonna wear gloves tomorrow. But yeah, right now it's fine. Nothing's gonna happen. Moving on, with the phone. What I had a problem with my phone is that probably like a year after I bought it, I broke the screen. So I got incredibly pissed off. It was a $1,400 phone, and I was very mad, right? It was like, did I just lose $1,400 by this stupid mistake of dropping the phone while I was doing something in my car, and now I cannot use it? So I decided that I was gonna fix my phone, and I got a screen, which at that time it was not even that cheap. It was like $300 for a screen, for a used one that had like a little bit of damage on it. And I changed it. And here's the screen. This is garbage actually. I don't know why I haven't thrown it out. But this is the screen, and it's completely broken. You can see it right here, right? And I changed the screen, and when I changed the screen, I damaged the battery slightly. So then the phone didn't work properly, and it smelled funny because the electrolyte from the battery was coming out. So after I fixed the screen, really the phone didn't work properly because of the battery. And then I opened it up again and I changed the battery. But again, the battery was not a newly manufactured battery because Samsung doesn't sell you a battery. And the phone worked better, but sometimes it kind of didn't work good at all. And this winter, so that was like maybe a year and a half ago when I fixed the screen and changed the battery. And when I fixed the phone, so then I changed the battery, and it worked good enough. Let's just put it that way. But then on this winter, with the cold, the phone didn't work again. The battery was dying. So then I tried to fix it again for a third fucking time. And lo and behold, I cracked the battery and the phone went into flames. So I have right now a really, really bad experience with fixing phones. It's just really stupid. I don't like it. You fucking break the phone, the shit doesn't work. So it just makes no sense to me anymore. I don't want to do it, to be completely honest. Wow, this thing is completely dead. What? I do not get a reading at all. Why? I have to go inside? Well, maybe not. Okay, so let's just take one battery, right? I am not gonna even bother with like. So what can I do here? So this is the charger. Now that I think about it, right? I was gonna take one battery out. Well, so let me finish the story. So I tried to fix my phone. I fixed it 3 times, and the phone never ever worked properly or as intended. So it was a really crappy experience, and it made me realize that when iPhone makes it so that you cannot open the phone and you cannot change anything, or Tesla makes it so that the whole car is controlled by like one module and the entire car is like one casting, it works and it's reliable. Yes, if you crash it, it's impossible to repair, or if you crack the screen, it's basically like, fuck you, get a new phone. But, at least when they work properly. They're not gonna just break down for whatever because of the cold, because the voltage on the battery was too wrong, because this manufacturing error that was made. No, it's properly made and properly put together, not meant to be taken apart, and it works. So that's one thought that I had that I wanted to tell everybody, that right to repair is good and all, but there's also some drawbacks. There are good things about something not really being repairable, to be honest. And phones have it. Tesla and Ford, in their way of making the cars, are taking the complete opposite approaches. We'll see, if one was more correct than the other. Honestly, I think both are good, to be honest. But let's see what's gonna happen. So now, moving on to this. This battery pack, I haven't charged it in a long time. So I actually didn't want it. I was giving it for dead, right? But now that I think about it, I kind of want to be able to charge it entirely, even if I take one battery out. So now I have to think about how I'm going to take this apart. Let me measure. So to explain to you guys what I'm doing, I'm trying to see, what's the voltage on these cells, because I don't know the chemistry. But when I put the probe on the battery itself, I'm not getting anything for a single cell. Nothing at all. But I am getting a voltage when I put the probes on the conducting bands. So this strips right here. But I'm only getting like 2 volts. So really the battery is very uncharged. Let's see what's the voltage when I connect the charger. And I'm gonna put shoes on because now, yeah. You cannot be that stupid all the time. Where's the charger? Oh. Okay, I'm gonna stop this. So it's green right now. Should turn into red. Turns into red. And I am getting 20 volts, 2.5. What? Is this like limited or something? What the fuck is this? 2.6, 2.7, or maybe it's something like 3 volts, what I should be getting. 2.6. Oh. Because you know how to turn my head and kiss me soft and slow. So right now he's a 0. If I disconnect this one, I think it can be okay, right? Yeah. Okay. So, right. So let's measure here. .86. If I disconnect, I am getting 2.8. Okay. So it is connected to everything. I mean, honestly, I don't know. I don't know which one would be the best. I think I'm just gonna go with this one on this corner. I think that's the easiest one to take off without damaging the rest. I have to cut this too and cut this one. Now this you should be really careful, because if you damage something, it really is gonna spark, and you don't want that to happen. Man, cutting this is gonna be fucking hard. What can I do here? This is flathead, right? There's no way this is real life. It sparked, you see? That, okay. You have to be careful. You have to be fucking careful. If this was way higher voltage, that spark would be a little bit bigger. Still not dangerous per se, but definitely not desirable. So you have to be careful. Okay, so that's one side. Okay, let's remove that. There's no way this is real life. That it feels right. That it feels right. That it feels right. That it feels right. Okay. So this has to go away. And now I'm gonna flip to the other side. And this has to go away. I think this is very, very thin aluminum coil or sheet. It's very malleable. Maybe in the future I'm gonna try to use aluminum like that. It seems very useful. I thought, because I've been looking into trying to buy aluminum on coils like this, basically rolls, but I haven't. But honestly, it is strong. It's not weak by any means. Now how does this come off? Does it come off through the top or through the bottom? So maybe what I have to do is make enough space so that the battery comes out. Oh, I see, because you kind of have to break the rest. Like, you have to take all of the line, of the conductive line, in order to make this plastic come off, which I am not gonna do. So I am gonna have to break it, but I don't wanna fucking screw this one up, because this, I can damage the cells. No, that shit don't break, man. What if I break it from here? Carajo. Okay. Okay, so I got it out. I had to grab it with this on the corner and take it out. So that's the battery out. I did damage it a little bit. I'm gonna show you. And you have to avoid damaging, because if you dent it too much, it's gonna short circuit. And when you short circuit, it's very bad. So that's one battery out. Now let's test it again. Let's see if it charges. If it charges, then I'm good. If it doesn't, then I'm not good. I did this for nothing. Well, not nothing, but let's see. Goes into red. Good. Shit, all this paper. I don't need it here. Let's just bring it down. Bring it down. 20 volts. Measure. negative, positive. So it is marked, fortunately. This came from two places, right? Yeah. So it is positive on top. .9 volts. What if I measure from here? 2.9. Everything 2.9. How about this one? 2.93. And let's measure the battery. Here and here. 2.7 volts. Okay. So I wonder, what is the correct voltage on these batteries? Oh, that's interesting. You know, this battery was starting to get damaged. Wow, that's actually pretty relevant. If you see here, there's a spot of rust. So this was gonna become dangerous to use at some point. Because if this breaks, it can short. Probably it was never gonna catch fire, but definitely it would have broken down. The battery would have just not worked as a battery properly. So that's interesting. That's definitely interessant. Now let's move on. Let's move on. So I'm gonna leave this here. Maybe I'm gonna charge it another day. This is off. So let's continue with the circuit, right? Okay, so first off, I confuse myself. I'm not looking for a transistor, I'm looking for a diode. And it's called Zener diode. The Zener diodes, usually no matter what voltage input they have, they change themselves into a specific voltage. The one specific to the one I'm going to use right now, I was wondering which one should I use, 3.9 volts or a little bit higher. I think what happens when you use higher voltage, you charge the battery faster, if I understand correctly. I think it's okay because I'm just using one cell. Definitely, you could test it out, do the math, and probably it's better to use 3.9 volts. Honestly, I don't know. But what I'm saying is this. The worst that can happen by using a 4.1, it's not even 4.1, it's 4.3. Oh, that's quite a bit higher, isn't it? Well, no, doesn't matter. As I said, I think I'm just gonna take the risk. I'm gonna try and see what happens. Maybe the battery doesn't blow up. Who knows? Let's just use a higher voltage. So yeah, transistors and diodes are completely different things. I was looking for a diode, a Zener diode. And right now, I am gonna Google, because that's a Zener diode, right? But there's a regular diode, and on that one it doesn't specify you what it does, because the thing is too small. It only puts like a part number. So I'm kind of curious. I'm gonna Google that part number, and maybe Google is gonna tell me what it does. I'm gonna do it right now. It's gonna be quick. What was it? IN1N4007. 1N4007. Single phase half wave What? Maybe it rectifies current? Average rectified 1 amp. DC reverse 1000 volts. Forward 1 volt 1 amp. Oh, I think it just rectifies the current. Maybe. Huh. Yeah, I think it's just like a rectifier. It just modulates current to 1 amp. Which then is interesting, because if I want to limit the current, I don't need to use a resistor, right? Oh yeah, so see, I'm learning now. First, it's not a transistor what I'm gonna put, it's a Zener diode. And then I have to put a rectifier diode, not a resistor. A resistor is just gonna be like putting a worse cable. No, it's a diode too that I need to put to limit the amperage. So let's grab one 4.3 volt 4.3 volts. Man, I think I am gonna have to get like a place to put all of this stuff in, because this is very quickly gonna become a mess, isn't it? Okay, so let's put over here. This I'm not gonna use today. So you go away, please. See what I mean? What the fuck is this? 2.7 volts. Man, this is so stupid. This is full. No idea. Let's just put it here. Okay. So that was 1 amp. Okay, let's not think about that one right now. I don't even know what amperage, cause I don't know. I guess there's one way I can figure it out. Maybe I can Google. Yeah, let me Google that. Oh, it's 5 volts. What? Oh yeah, so okay, so that makes a little bit more sense. That I was not wrong. I was thinking, if I remember correctly, the amperage is kind of decided by the cell. The cell itself, it is gonna draw in as much current as possible as it can, chemically possibly. Well, chemically possible, and as it charges more, the current actually is gonna go down. So I don't need to actually limit. No, I do need to limit the current to the capacity of the diode, right? Which is actually, I think it's like a lot. I don't think I need to worry about that one. If anything, these melt, right? They don't explode or anything. They just melt. So okay. So I continue with the plan. Let me change from 4.3 to 4.7. Or you know what? Let me use 5. Let me use 5 volts. So this is 18, 6.8, 27, 30, 3.3, 9, 3.9, 6.2, 12, 24. Can I find it? 5.1 volts. Yeah, this works. So let me use this one. I'm going to use one of this. Let's put one of this here. So this connects into this. The limiting current, I don't think it matters for now. And then this is gonna connect directly into an LED. So I put right here, when this reaches 3.7 volts, I am gonna make an LED flash. Can you do that with a diode? I don't know. What type of diode would that be? No idea. Maybe it has to be an IC box? Because a capacitor is gonna always get charged. The Zener diode's always gonna make one current specific. Oh! That one has to be a transistor, right? I can make it so that the transistor is grounded and current, and the pin, if it doesn't have a certain capacitance, a certain voltage, is not going to let the current through. Okay, so that can be done with a transistor. I need to search which transistor though. But first, let me actually try these two pieces. I have this here. So I cannot connect this. The power supply has to connect. Oh my goodness gracious, what a fucking mess. Okay, so this too. Oh my god, man. Los cables. Ugh. What the fuck is this? Oh yeah. Okay, so let's grab this. I need a pin cable. So let's grab no, this is not it. This is not what I want. So let's positive, negative. How do I do this? Okay, I know it. I am gonna solder. Is this on? Yeah, this is on. It's gonna get hot, right? Is this on or no? Is it connected? Yeah, I can see a light. Oh yeah, it's starting to. Oh, it's hot. Okay, let's give that a couple of minutes. Fucking cable mess here. Jesus Christ. Okay. So I am gonna solder a couple of cables into the battery, right? So I'm gonna solder this into the battery, and then I am gonna connect this into the board. And then I need 2 more cables going from the board into the power supply. So I need 2 more cables. Let's grab this one and this one. And this can be grabbed by this. Oh yeah, this is good. This is more than good. Yeah, this is good. So, this is gonna be negative. This one's gonna be positive. So, negative, positive. Let's connect this. That's not working. Fuck me. Tiene pelos. Dios mío. Tiene pelos. Okay, so that's one. Doesn't come off. Fuck me. Now, what's gonna hold this? How can I hold this? Because this cable doesn't melt, right? No, this cable doesn't melt. Not even close. I need to solder. Yeah. Let me turn on the fan, and this is good. Good enough. Good enough. Good. Oh. So, that's off. Hace frío, carajo. Dios mío, y el ventilador ya me está pegando todo. Let's see. 2 volts. Which is positive. Maybe I shouldn't have used the same colored cable, okay? For next time. Which is positive again? This is positive, okay. Serio, pensé que nada iba a pasar. Dios mío. Fucking pésima idea. Oh, ¿es en serio? Y no funcionó. Why though? It is connected. What do you mean? Positive, negative. No, what do you mean, bro? 20. Oh. Ay. Bueno, qué bueno que no se quemó. I had my multimeter in low voltage setting. This is a little bit not low voltage. So good. It works. Let's proceed. The diode, 5 volts diode. So, no matter what voltage goes into the diode is always gonna charge into 5 volts. Yeah, that's what's supposed to happen. So let's use one. This is 5.1 volt diode. And I don't remember what's the direction of the diode. If I remember correctly, It is colored, no? There's a line. Oh, and it does say how many amps. It's 33 amps. $33 amps, something 73 LT. Man, I fucking need magnifying glasses. So I guess we're just gonna have to test out. There's really nothing I can do. So I have to connect the diode. Let's say this is negative and this is positive. So if I connect the diode, negative to positive, negative, positive. I'm missing a cable for each one, so I have to connect the cable cable. So I have to connect from here to here. And a cable from here to here. So negative, positive. And then I want to connect this is wrong. So what does this do? This connects okay, so I need to connect the negative into the load. So let's say from here to here, and then connect this negative to positive. Man, I've never done this before. So this is wrong again, no? Maybe? I think because, well, let's see. I mean, I guess we're gonna find out, right? What happens if I do this? If I do this, is this correct? $20 direct current. Does this have any measurement at all? It actually does have a measurement. 2.73. ¿Y ahora? La pantalla está toda blanca. Let's turn everything off. And it actually has a load. Oh, so it's discharging the battery right now. What? Positive, negative. Two 2.73. And here? Oh, come on, bro. What do you mean nothing? 2.8. And let's increase it to 5 volts. Voltage, increase, amperage, increase. How many amps? Let's put 2 amps. So 2 volts, 3 volts, 4 volts, 5 volts. So let's put 5 volts on whatever amperage you want, bro. Fine. It's not letting me change the amperage, but I guess it's because there's nothing I can do. So if I measure from here to here, I should get 4.6. But if I measure from here to here, 2.9. I think I understand what's going on now. The battery, it's regulating the voltage. .9 volts. 7.3 volts. 2.95. What about if I take the current off? So what happens now? From here to here. Oh. Okay. So this is most definitely very interesting. So let's go back to 5 volts. So here's the thing. I want to turn that thing off. Let's see how long does it take to charge. It's negative, positive. What is going on here? But the thing is off. Again, from here to here. 2.94. And if I turn it on, I have 5 volts and I'm getting 2.94. 2-volt difference. No, honestly, I'm not understanding something. I am a little bit lost. I think I'm gonna figure it out by tomorrow or some shit. But I'm kinda lost. I don't know if the diode is backwards. I don't know if the battery is charging or not. Because it marks 0. What do you mean 0? Makes no sense, bro. What do you mean 0? Okay, what if I disconnect everything? Okay, disconnected. Positive, negative, yeah. $2.94. Huh. Okay, I want to do something then. Let's completely skip the diode and just connect it directly onto the power supply. So if I connect here and I connect here, and if I turn the machine on, what's the reading? So it has a minimum of 3 volts, and I can go up more to 4 volts, and it gives me more amperage. Oh wait, that's the amperage. No, I want 1 amp. And the voltage, it has a minimum, and it can go up to... It doesn't do anything. What? Oh, I have to increase the voltage, the amperage. So the diode is definitely doing something. I mean, so 4.3 and 2.1 amps, right? 4.3 volts, 2.1 amps. Now let's disconnect and connect it into the diode. Six volts, no amperage. Then maybe the diode is backwards. But it's increasing it to 6 volts though, no? Although the diode is supposed to be 5 volts. Well, I mean, let's put it backwards, see what happens. So I'm gonna connect it now this way, with the black bit into the front. Is that connected? Yes, that's it. So in here, in there, negative, positive. What now? 6 volts? No. So I think I have to do something. Hace frío. Dios mío. Let's just connect this directly and see what happens. So if I connect from here to there, and I turn it on, what happens? 6 volts, no amperage. But can I up the amperage? No. I can change the voltage, but I cannot change the amperage. Oh, I shouldn't measure it from there, right? Okay, so let's do 3 volts and measure with the multimeter. So if I measure from here to here, what's the reading? 0. Because that's the same side. Here to here, still nothing. Oh, there's nothing. Oh, maybe it's backwards? Maybe it's backwards. Man, fucking half an hour just to figure out how to fucking connect the diode. Okay, like that, like that. Give me something, bro. Can you do something? Okay, so again, if I connect from here to here, 3.4, and here to here, isn't this part supposed to be 5? Measuring 0. No, I'm wrong. It limits the voltage. So let's put 8 volts. And it should always be 5 either way. Right? I think that's how it's supposed to work. So from here to here, 8 volt. From here to here, here to here, I'm getting 0. But maybe it could be because there's no load. Okay, let's connect it backwards. Again. Here and here. Oh my god. Oh my god. De aquí a acá, 8 voltios. De aquí a acá, nada. But maybe that's because there's no load. But the thing is though, if I connect the battery directly, the battery is gonna limit the voltage. No? No. No, because at some point it increases the amperage, if I saw that correctly. So let's see, positive, negative. Right now it's 8 volts, but the diode is connected. So in theory, this shouldn't pass 5 volts. Eight volts, 3 volts. means something changed. I was getting 0, I think. So now I'm getting 3 volts, which is something. 8 volts, 3 volts. With the battery connected. 8 volts, 3 volts. What if I flip it again? Eight volts, 3 volts. Maybe I've discovered something. It's just you cannot put a diode in front of a battery. Maybe that's how it works. I think maybe that's what's going on. Maybe you shouldn't put a diode in front of a battery. Because clearly it's not doing anything. Well, I learned something today, I guess. 3.1, and this is 8 volts. What about amperage? Continuous current, 10 amps. Negative to positive. 0, 0. 0 and 0. It's not doing anything. And this measures amps too, so yeah, that works. Yeah, I don't think you can connect a diode behind a battery. It just makes no sense. I think it's a mistake. I think you just shouldn't do it. It defeats the purpose. So I'm done. I'm tired. So, turn it on. Let's turn everything off. And it actually has a load. Oh, so it's discharging the battery right now. What? Positive, negative. Two 2.73. And here? Oh, come on, bro. What do you mean nothing? 2.8. And let's increase it to 5 volts. Voltage, increase, amperage, increase. How many amps? Let's put 2 amps. So 2 volts, 3 volts, 4 volts, 5 volts. So let's put 5 volts on whatever amperage you want, bro. Fine. It's not letting me change the amperage, but I guess it's because there's nothing I can do. So if I measure from here to here, I should get 4.6. But if I measure from here to here, 2.9. I think I understand what's going on now. The battery, it's regulating the voltage. .9 volts. 7.3 volts. 2.95. What about if I take the current off? So what happens now? From here to here. Oh. Okay. Okay. So this is most definitely very interesting. So let's go back to 5 volts. So here's the thing. I want to turn that thing off. Let's see how long does it take to charge. It's negative, positive. What is going on here? But the thing is off. Again, from here to here. 2.94. And if I turn it on, I have 5 volts and I'm getting 2.94. .2 volt difference. No, honestly, I'm not understanding something. I am a little bit lost. I think I'm gonna figure it out by tomorrow or some shit. But I'm kinda lost. I don't know if the diode is backwards. I don't know if the battery is charging or not. Because it marks 0. What do you mean 0? Makes no sense, bro. What do you mean 0? Okay, what if I disconnect everything? Okay, disconnected. Positive, negative, yeah. .94. Huh. Okay, I want to do something then. Let's completely skip the diode and just connect it directly onto the power supply. So if I connect here and I connect here, and if I turn the machine on, what's the reading? So it has a minimum of 3 volts. And I can go up more to 4 volts. And it gives me more amperage. Oh wait, that's the amperage. No, I want 1 amp. And the voltage, it has a minimum. And it can go up to... It doesn't do anything. What? Oh, I have to increase the voltage, the amperage. So the diode is definitely doing something. I mean, so 4.3 and 2.1 amps, right? 4.3 volts, 2.1 amps. Now let's disconnect and connect it into the diode. Six volts, no amperage. Then maybe the diode is backwards. But it's increasing it to 6 volts though, no? Although the diode is supposed to be 5 volts. Well, I mean, let's put it backwards, see what happens. So I'm gonna connect it now this way with the black bit into the front. Is that connected? Yes, that's it. So in here, in there, negative, positive. What now? 6 volts. No. So I think I have to do something. Hace frío. Dios mío. Let's just connect this directly and see what happens. So if I connect from here to there and I turn it on, what happens? 6 volts, no amperage. But can I up the amperage? No. I can change the voltage, but I cannot change the amperage. Oh, I shouldn't measure it from there, right? Okay, so let's do 3 volts. And measure with the multimeter. So if I measure from here to here, what's the reading? 0. Because that's the same side. Here to here, still nothing. Oh, there's nothing. Oh, maybe it's backwards? Maybe it's backwards. Man, fucking half an hour just to figure out how to fucking connect the diode. Okay, like that. Like that. Give me something, bro. Can you do something? Okay, so again, if I connect from here to here, 3.4, and here to here, isn't this part supposed to be 5? Measuring 0. No, I'm wrong. It limits the voltage. So let's put 8 volts. And it should always be 5 either way. Right? I think that's how it's supposed to work. So from here to here, eight volt. From here to here to here, I'm getting 0. But maybe it could be because there's no load. Okay, let's connect it backwards. Again. Here and here. Oh my god. Oh my god. De aquí a acá, 8 voltios. De aquí a acá, nada. But maybe that's because there's no load. But the thing is though, if I connect the battery directly, the battery is gonna limit the voltage. No? No, because at some point it increases the amperage, if I saw that correctly. So let's see, positive, negative. Right now it's 8 volts, but the diode is connected. So in theory, this shouldn't pass 5 volts. Eight volts, 3 volts. I mean, something changed. I was getting 0, I think. So now I'm getting 3 volts, which is something. 8 volts, 3 volts. With the battery connected. 8 volts, 3 volts. What if I flip it again? 8 volts, 3 volts. Maybe I've discovered something. It's just you cannot put a diode in front of a battery. Maybe that's how it works. I think maybe that's what's going on. Maybe you shouldn't put a diode in front of a battery. Because clearly it's not doing anything. Well, I learned something today, I guess. 3.1, and this is 8 volts. What about amperage? Continuous current, 10 amps. Negative to positive. 0, 0. 0 and 0. It's not doing anything. And this measures amps too, so yeah, that works. Yeah, I don't think you can connect a diode behind a battery. It just makes no sense. I think it's a mistake. I think you just shouldn't do it. It defeats the purpose. So I'm done. I'm tired. $3.7. So, I mean, I can charge a battery. It's just connecting a diode into a battery is just not a good idea. What I do know is that. So, I guess that's it for today. Everything else is I'm just gonna have to think. But that's it. And lastly, I learned that these cables don't handle more than a couple of amps because they melted. My goodness gracious, that's bad.